Okay, folks, I want to record this very short video on the kinetic isotope effect. This is something that I think has a pretty happy, feel-good outcome, even though it can be mathematically complex. So let's describe it as simply as we can. So the kinetic isotope effect is the decrease in the rate of a chemical reaction upon replacement of one atom and a reactant, specifically by a heavier isotope, right? So the reaction gets slower if we replace it with a heavier isotope. So, and the rationale behind that is given if we look at the potential energy surfaces. So for example, let's suppose we replace a CH bond in a molecule with a CD bond. So we could get into the hideous detail from quantum mechanics showing that the CD bond will be lower in energy than the CH bond. And simply what that means then is for the replacement of that hydrogen with a heavier isotope, the activation energy is now larger. And it's larger enough that it makes the reaction significantly slower. So this is some complex math that I'm not really going to derive. But what I do want to point out is if we look at the rate constant from CD to CH, it goes e to the negative z, where this parameter z can be calculated as the following. And what's important to note here is it's the square root ratio of the reduced masses. So for a CD and CH bond, this ratio is approximately 0.5. And so what's important to note about that, 1 minus 0.5 gives me 0.5. Importantly, that means this is a number greater than 0. And there's already a negative sign in this equation. So that means KRXN for CD must be less than KRXN for CH. So typically the way that we use the kinetic isotope effect is to prove a mechanism. So for example, if we deuterate our sample and it doesn't really change the rate constant by very much, then we can conclude the rate determining step was not involved in breaking this bond. However, if we deuterate this sample and we see the reaction slows down significantly, then we can conclude that the rate determining step did involve breaking of that bond that we isotopically labeled. Okay? So that's all that I really want to say about that. It's a pretty straightforward thing. The math is complicated, but it's got a straightforward result. Elementary reaction will decrease if we replace one of the atoms by a heavier isotope, and if that atom is involved in the RDS, the rate determining step. If that portion of the molecule is not involved in the rate determining step, then we won't see it change the rate constant. And that's also a positive result for doing isotope replacement. Okay, that's all I wanted to say about the kinetic isotope effect. I'll see you in the next video.